Hello everybody, this is Mr. Longo here, and this video is going to cover summation, which is the sum of a sequence. And we're going to use a symbol known as sigma from the Greek alphabet, and sigma looks like this. It's a fancy E. And then of course sigma represents the sum of a sequence going all the way up to a sub n. And what we're going to do here is, for summation, k is your starting term. And the top of the sigma is where you're going to stop. And then, of course, it's whatever your formula is. So we're going to write out each sum for these first couple examples because we're given what the summation equation is. So to write out each sum, you have to start at the first term and stop at n. Well, I know what you're thinking already is, how do you stop at n? Well, you don't, really. You just do it the first couple. So the first term you would do is k is 0. So that would just be 2/3 to the 0 power. Plus, then you would do 2/3 to the 1 power. Plus, 2/3 to the 2 power. And then you can just put plus, and then you can put a couple of dots, and finish with plus 2/3 raised to the n power. So of course 2/3 raised to 0 is 1, plus 2/3 raised to the first power is 2/3. 2/3 to the second power is 4/9, and then you would just do that plus dot 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 all the way to 2 to the n over 3 to the n. Now you only have to do that if you are stopping at n, which means you're just kind of coming up with a pattern. In an example where we have a start and a stop, we can actually add those up. So this one would be 3 times k minus 1. So we're starting at 0. So this is just 3 times 0 minus 1 plus 3 times 1 minus 1 plus 3 times 2 minus 1 plus 3 times 3 minus 1, and that's where we're supposed to stop. So 0 minus 1 is a -1 plus 3 times 1 minus 1 is 2 plus 6 minus 1 is 5 plus 9 minus 1 is 8. And if you were to go add all of those up, you should end up with 14. Okay, so you can, if you know where you're starting and stopping, you can actually add them all up. So why don't you pause the video and try the next one. It does have a start, it does have a stop, so find the sum of -1 to the k times 2 to the k plus 2. Just pause the video, give it a shot, click play when you're ready. So our starting is 2, we're stopping at 4, nice short one. So we have -1 squared times 2 raised to the k plus 2. So 2 plus 2 would be 4 plus -1. And now we're at our third term times 2 to the 3 plus 2 is 5 plus -1 to the fourth times 2 raised to the 4 plus 2 is 6. So -1 squared becomes a +1. 2 to the fourth is 16, so we have a 16. And now we have -1 cubed, which means we're going to have a negative. 2 to the fifth is 32, plus -1 to the fourth power is +1 times 2 to the sixth, which is 64. And then we just need to combine those. So 16 minus 32 plus 64 is going to give us 48. So if you got 48, you're good to go. All you're doing is substituting in k 3 different times for 2, 3, and 4. So this, of course, will be the tricky part. How do you come up with the sum formula? And since this is going to be similar to the previous patterns, you kind of know what to start thinking. Now, one little tip I'm going to tell you is you should count your terms and figure out where you're starting. Well, if you're given a sequence, you obviously are going to be starting with the first term. So we're going to start by saying our first term is k is equal to 1. And we're going to stop at, we have a sub 1 all the way, we stop at a sub 5. So we're going to stop at 5. And now we just need to figure out a pattern. So how do you get from 2 to 5? We're going to add 3, and now we're going to add 3, and now we're going to add 3. So this is linear. So this pattern is going to be 3 times k. But we need to see if 3 times k actually gives us what we're looking for. So if we were to substitute k in, 3 times 1 is 3, not 2. So we actually need to subtract 1. And now test a couple, and you can test them in your head. So what if k was 2? So a sub 2 would be 3 times 2 is 6 minus 1 is 5. Yes, we got it right. Okay? So again, it's just creating a pattern. The only thing that's different now is we have to put our summation symbol in front and talk about our start and stop. All right, so why don't you pause the video and try the second one. This is going to have that little trick with the -1 that we talked about before. And it's not going to be constant either. There's going to be some multiplication to this as well. So why don't you give it a try. It is tough, but give it a try first before I explain it. Okay, so you probably noticed that to get from -2 to 4, and then you're going back to negative, then you're going back to positive. So this is where we taught you before, ignore the symbols for now. From 2 to 4, you add 2. From 2 to 8, you add 4. From 8 to 16, you add 8. And then, of course, after that, we're going to add 2, add 4, and it's going to give you the same pattern. So since that doesn't work, we're going to try multiplication. So 2 times 2 is going to give us 4. Times 2 is going to give us 8. Times 2 is going to give us 16. So since it's based on the original pattern, and you're just going to multiply the previous term by 2, this is exponential this time. So something to do with this is going to be 2 to the k power. And we're not, again, adding or subtracting. That comes from the original pattern. But we do need to take into consideration that -1. So the question of the day is it k or k plus 1? Well, our first term is negative. So -1 to the first power is still -1. Okay, so now we just need to write our sigma. Our starting term is obviously k is equal to 1, and we're going to stop at, that's the next part of this puzzle. Where do you stop? Well, we have 2, 4, 8, 16, 32. That's 5 terms. Then you have 64, and 128, and 256, and 512, which means this is all the way going out to a sub 9. That's our 9th term. So we're stopping at 9. So see, there was a couple of parts to that puzzle. All right, and the last example, this one's pretty simple. The only reason I did this example is so you can see one that has no ending. So it's very obvious. This is 1 squared, 2 squared, 3 squared, 4 squared. So this is just k squared. So we have the sum of terms k squared. And we're going to start, of course, at k is equal to 1. 1 squared, 2 squared, 3 squared, 4 squared. And it goes on forever. So if we don't know when to stop, we just say that we go into infinity. And that's it. That's how we represent that sequence, because we don't know when we're stopping. All right, so that's just the sum of infinite numbers, which of course is infinity. So anyway, that's a video on summation. This is Longo and I'm out. See you, bye.